This is examples number 3 and 4 for electricity, and these specifically are about capacitance. And capacitance is just a measure of the amount of stored charge on a conductor for a given potential difference. So there was a gentleman by the name of Pieter van Musschenbroek, and in 1745 he and his assistant actually charged up something called a Leyden jar. And the Leyden jar is the device that you see here. On the inside, it's got some metal, and you charge it up, and when you do that, it gets somewhere around 10,000 volts. So the voltage for this is about 10,000 volts. And it had a charge of about, so our Q here is equal to 5 times 10 to the negative fourth coulombs. And when he touched it, he said that he got such a large jolt that he exclaimed he would never try the experiment again for all the Kingdom of France. They want us to figure out what is the capacitance of that jar. Capacitance, the equation is C is equal to Q over V, where Q is charge, V is voltage, and the capital C here is capacitance. Be really careful because the unit for capacitance is called the farad, and it's abbreviated with an F, and the unit for charge is the coulomb, which we know is a capital C. So don't get the two C's confused. So those two C's, be very careful. They are totally different. If we want to find the capacitance, we can say C is equal to Q over V. And let's go ahead and put our Q in, which is 5 times 10 to the negative fourth coulombs. And we'll divide that by the 10,000 volts that was stored in that Leyden jar. If you do your math, you should end up with 5 times 10 to the negative 8 farads. And so we just use a capital F for it. For the next example, which is example number 4, Lydia pushes the shutter button of her camera, and the flash unit releases a brilliant flash to light up the picture. When it does that, it releases a charge of about, so here we know that this is the flash, it's releasing a charge somewhere around 4.5 times 10 to the negative 13th coulombs. And it's stored on a capacitor, and that capacitor is 500 microfarads. At this point, remember, we need everything in base units. So this micro, if you look on your equation sheet, we know that it would be 500 times 10 to the negative sixth farads. We need to figure out what the voltage is, and if you remember our equation from before, we said that C is equal to charge divided by voltage. And so for this one, we're going to say that voltage is equal to charge divided by the capacitance. Our charge was 4.5 times 10 to the negative 13th coulombs. And we know that our capacitance was 500 times 10 to the negative sixth farads. So if you do your math, you should end up with the same answer I have here, and it is 9 volts. And a 9-volt battery, if you have ever seen or used a 9-volt battery, it's the one that's a box and it's got 2 terminals on the top, and you would just put that inside of the camera flash here in that little spot, and that would be it.